This is number HRW94P029. It's so short that I wrote it. We've got a projectile's launch speed is, here they give you a number, but I'm going to use n, just some multiplier n, some number, times its speed at max height. Find the launch angle. Okay, so we've got something being launched like this, at some velocity, and at some angle. The thing is, when it gets to maximum height, basically, so it falls something like this. At its maximum height, the velocity in the y direction is 0, so whatever velocity it has here is all in x. And since x velocity doesn't change, since gravity does not act this way, what we really have is this is equal to the initial x velocity as well. So I know that it says the projectile's launch velocity is n times its this one, so v naught in the x direction. Oh, come on, there we go. And v naught in the x direction is equal to v naught cosine theta. So put that in there, and I get v naught equals n times v naught cosine theta. I want to solve for theta, so I got to get rid of everything else. So let's get rid of everything else by dividing by n and v naught. N and v naught. Oops. Sorry, squeeze that in there. So these are gone. Notice these are gone too. So what I end up with is 1 over n equals the cosine of theta. To get a theta, instead of the cosine of theta, I have to undo the cosine, which means taking the inverse cosine of both sides. So I end up with the inverse cosine of 1 over n is equal to the angle. And you just pop in your number there and use a calculator and you're done.